This is the racking system on an ATC all aluminum fifth wheel toy hauler, and all of this is installed without the use of any bolts or screws or anything that puts a hole into this. So everything is attached using stainless steel hardware and VHP tape, just like the coach. So I'm going to go ahead and give some details into how I did this. Now you can see that we have horizontal pieces laid down every so often. That's because there's actually, that corresponds to exactly where the support strut for the roof is located, so the two pieces are sandwiched directly on top of each other. And you can see that slight change in coloration right there where I actually VHB prepped the roof for any additional supports if you wanted to add something there. Now the main reason we went with this rail system is it allows for pretty much any panels that fit up here to be mounted and then swapped around easily. So we're going with 215 and 300 watt panels respectively, but next year we could get a panel that perfectly fits this roof that could be 500 watts and really not much longer, and then we can just go ahead and swap those in and out. On a similar system, you could do the whole roof in about 2 hours with 2 people and a ladder. So pretty easy peasy. You're just taking off the standard solar mid panel clamps that we're going to use with this system here. So let's go down to the details of how we did our riser system, because this is different. The last time I did this, I used the standard unistrut hardware, which is stainless steel, and it was pretty heavy actually. It added a lot of weight to it with the spring nuts and everything. So what we have here is we're going to go with a single spring nut to which a threaded rod has been attached to it. It runs through there, and we're using Loctite red to permanently lock it down. And then that's going to get some upward pressure, and it's going to bite into the teeth on each side of this channel with these teeth right here. So that's going to help to really lock it in once it gets nice and square. See if I can get that in there. So you can kind of see how those teeth lock in and bite into the aluminum, as this is a steel piece and it's harder. So there you can kind of see it right there, kind of biting in. And we put this piece of unistrut on there because this will actually prevent the T-nut from actually being able to wiggle out, because the way that it's put in is you put it in sideways and then you rotate it to lock in place, which I can't do with one hand. And if it's not allowed to rotate, then it's permanently locked into place, which is why we're using this piece of unistrut here, which helps to just to make sure that any kind of vibration or anything is not going to pull it out. And then the tension is actually created on this piece of unistrut that actually just pulls the two together, because we're going to use these double washers right here. Now the larger washer is the full length of this, and because of the way it's designed, once you have one washer in, it's impossible to get another one of the same size. You can only get one, just by the way it locks in there. And if you ever need to pull it out, you can't take the washer out of the top, you got to slide it out the end. But the smaller washers can be added in, as many as you want. You take them in and out easy peasy. We just use these larger washers for alignment, because then it's perfectly centered in the middle of this, whereas in this one right here would give you a little bit of play. If you're looking for the play because you're not exactly perfect with your strut alignments, then smaller washers would be ideal. But I measured everything, so we went with larger washers. And this is significantly lower in weight, and in order for this to fail, we would actually have to have this 1/4-inch threaded rod actually shear off, and that's pretty unlikely because we're not putting this under a lot of tension. We're going to let the blue Loctite do its job, and we're just going to make sure that these doesn't rotate out of place, because this is not pressed down with a lot of tension in order to really torque it in there. It's just enough tension so that those teeth bite in, and that this piece has absolutely no give to it and no sway, as I really put all of my body weight into this. And I've also done that with 2 hands, and this definitely supports the entirety of my weight and my movement. So that's the design that we have for this. And this is exceptionally lightweight, coming in at less than half a pound per foot of material. And I don't know how much material that I have used off the top of my head, as we had a slight design change, which is to actually just bend the unistrut around this fifth wheel curved roof. Because with the tall unistrut, that type of horizontal bend is not possible. But with this type of unistrut, I was able to get that really nice curve that we're looking at here. So, got a nice curve, and well, in terms of measuring the bolts, the bolts that actually stick out over the top like this are totally fine, since the solar panels are high enough that that there's about an inch of gap between the top of the glass and this right here. But I'm actually just going to snip them off so that the solar panels can slide more easily. Because we did several sizes of these to get all the different risers correct, so that we can get a nice gradual slope that doesn't interfere with anything. So we have a nice gradual slope on this. I'm not sure if you can see on the roof how it does slide down. And you can see the notch that I cut there for the initial end plate, but our panel will end up being moved a few inches away from the front, which is ideal because our panels are going to be located all the way up to the edge, but not sticking over the edge of the roof in this design, so that we can keep them away from the shadows that will be introduced by the air conditioners and the fans when they're turned up. This was about $2,500 in material costs, maybe a little more, since I just had to buy some more solar mounts for another $180. So it gets up there pretty quickly in comparison to the less expensive methods, but by covering almost the entire roof, with the exception of the air conditioners and the vents, with solar panels, we're going to effectively put this thing in the shade all the time, and that's going to have a significant amount of impact on how hot this roof is. Because if you come up to here on a hot summer day and touch this roof after it's been in the sun, it is a scorcher. But that is not the case when they are underneath panels that are elevated like this. These panels are elevated, I want to say maybe 6 or 7 inches off the roof, but it does not add any additional height, as the air conditioners are still the tallest thing on this RV, because this was a maximum height RV and we did not want to make something taller than its current maximum height, which is why we have this, because otherwise we could get a bit more solar onto this if we were able to cover the whole thing. But we currently have 6 of the 300 and something watt panels and 7 of the 200 and some watt panels. So we've got a lot of power up here. We got 1400 watts plus 1800 watts. So that's a lot of power, but it could be a lot more, and you could really have some fun and luxury with this thing. So this is the build, and we're going to go ahead and put the solar panels up here later on today. After I got everything checked out, I just wanted to take some videos, because once the panels are on, you really won't be able to see much of anything. It's just going to kind of look like that. You will notice that there's a few gaps in the rafters, because I found it not necessary to use every single structure, because the amount of VHB tape that we have down and the wind forces, like, there's no way this thing is coming off, because all of the pieces are attached together as a single piece. So you're not going to have like a panel fall off. Like, if this thing comes off the roof, the whole thing's going to come off the roof, because we're also going to have steel cable that loops through the panels and goes into this. So even if we do have a mid-clamp failure, our panel's still going to be held on with a steel cable, and the chances that you're going to have some kind of double failure before the sound of that panel rattling around on the roof alerts you is pretty rare. but we're just giving it the absolute best security that we can. You don't cut any corners when it comes to this kind of stuff, because this type of vehicle, it's easily going to hit 100-mile-per-hour winds, and it needs to be able to handle that without issues. So this is going to be able to handle 150. That's why you have to get solar panels that have an exceptionally high wind rating and snow rating if you're going to use these in an RV. But then again, the whole thing is a premium product, and it's built to withstand that. That's why we're using all stainless steel and aluminum here, and the whole coach is aluminum as well, because even if it leaks, which it won't because we put no holes in, it wouldn't necessarily do any damage. But it's just about doing things the right way, and it should last for a very, very long time.